Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 1.4 entitled Equations and Inequalities. And today's objectives are going to be to determine if a given value is a solution to an equation or to determine if a value is a solution to an inequality. And then we're also going to use some mental math skills to help us solve an equation. An equation is a mathematical expression that's set equal to a numerical value or another expression. And an equation has to have an equal sign. So some examples of this might be a plus 3, which is a mathematical expression, equal, got to have that equal to sign, equals 9. So there's an equation. Or you could have 3x plus 1, getting a little more complicated and fancy here, equals 7x minus 5. So you could have an expression set equal to another expression. Now we're not going to see anything that complicated yet. Today we're going to see something more like this first expression or equation that I wrote. Now when you have a single variable equation, you can substitute a value in for the variable and then figure out if that statement is true or false. If the statement's true, then the value that they gave you is the solution to the equation. And if it's not a true statement, then it's not a solution. So to do problems like that, your book will say, check if the given value is or is not a solution to the equation. And sometimes students get a little confused just by the way that these problems are written and the way the formatting is. This first part, the 3x plus 1 equals 7, that's your equation. The x equals 2, that's the value that they want you to substitute in for the x. So they separate the 2 by a semicolon. So don't think that there's two equations or two equal signs, or don't let it overwhelm you. Okay? All you have to do is take that value and substitute it in and see if you get a true statement or not. So in this case, 3 times 2 plus 1 will equal 7. And then you're basically going to simplify this stuff on the left side. So you're going to do order of operations. You're going to multiply. 3 times 2 is 6 plus 1. And 6 plus 1 is 7. And 7 is indeed equal to 7. So yes, that value is a solution to that equation. For part B, here again, here's my equation, 7x equals 28. This is the value that they want me to substitute in for that x. So 7 times 3 equals 28. Now you should know that 7 times 3 is 21. And I hope you know that that is not equal to 28. So no, that value is not a solution to that equation. And my last problem here has a fraction, sort of. You could think of it as x over 2 or x divided by 2. So you could think of it as a fraction or think of it as division if a fraction makes you feel a little nervous. But again, here's my equation, and here's the value that I'm going to substitute in for x. So I'm going to have 20 divided by 2 plus 3 equals 7. Now to simplify, on the left side, I'm going to take 20 divided by 2, which is 10, plus 3, and 10 plus 3 is 13. That is not equal to 7. So again, no, that value of 20 is not a solution to that given equation. So it's more practice with substitution and order of operations, but it's getting you prepared to find solutions for equations. So instead of just checking a solution, we can also find an exact solution. And this is solving an equation. Now, for right now, we can just use mental math. Some of you might have learned the algebra to solve this, and you might be comfortable doing that right now, which is fine, but I'm not going to require it until we get into chapter 3. So even the directions will say use mental math to solve the equation. So here we have x plus 4 equals 12. So something plus 4 has to equal 12. And that something, that x value, is going to be 8. 8 plus 4 is 12. Now if you were doing the algebra to solve this, you would subtract 4 from both sides of the equation to get the x by itself. And then 12 minus 4 is 8. So that's what we will be doing in the future. For part B, here we have 2x, or 2 times x. So 2 times something equals 18. So I hope you know that 2 times 9 is 18. So x is the value of that variable. I'm sorry, 9 is the value of that variable. Now part C, this is meant to be a little challenging. This is going to make you think. Okay, this is something to the third power equals 27. Now remember when we were dealing with exponents, that meant that we had something times itself 3 times. When you have something cubed, it means you have something times something times something. That has to equal 27. So you might need to guess. Again, we're using mental math. So you could say, is it 1? 1 times 1 times 1? Nope. Is it 2 times 2 times 2? Nope. Is it 3 times 3 times 3? Yes, it is. 3 times 3 is 9, times another 3 is 27. And as we get into second semester, we'll talk about square roots and cubed roots and fourth roots. And taking roots is how you would get rid of an exponent. So here we want to take the cubed root of both sides, and then you take the cubed root of 27, which is 3. But again, for now, just using mental math, doing some guessing and checking is totally acceptable. Now we don't just have to have an equation, we can also have an inequality. And we can check the solutions for them as well. Now remember your signs here. Sometimes students get a little confused. These are your less than signs. We have less than, and then we also have less than or equal to. This one is the greater than, or greater than or equal to. So if it has a little line under it, that's the equal to part. So problems in your homework that are going to have you doing this skill, though they will say, check to see if 3 is or is not a solution to the given inequality. So they tell you the value of x is 3. So they just want you to take that value and substitute it into the problem and see if you get a true statement. So now instead of being an equal sign, it's just going to be a less than or a greater than sign. And you're still looking for that concept of a true statement. So if I substitute in a 3, I'll have 3 times 3 minus 2 is greater than 5. And I'm going to simplify the left side so I can get one number. So it's 9 minus 2 is greater than 5. And 9 minus 2 is 7 is greater than 5. So now that I have one number on each side, I have to say, is that a true expression? Is 7 greater than 5? Then yes, that is true. So x equals 3 is a solution to that inequality. For part B, I have to take 4 times 3 squared and set it less than or equal to 32. And remember, the only thing that's being squared here is the 3. So this is 4 times 3 squared is 9. It's less than or equal to 32. 4 times 9 is 36. And when you're dealing with the less than or equal to, or even the greater than or equal to, you really have to consider both options. Is 36 less than 32? No, it's not. Is 36 equal to 32? No, it's not. So for both of those cases, you get a no, so that means nope. X equals 3 is not a solution for that inequality. Now, if we would have had an expression like 31 is less than 32, that would have been a solution because 31 is less than 32. It's not equal to 32, but it is less than. So as long as one of those conditions is true, then it will be a true statement. But if one of them is not true, or definitely if both of them are not true, then it's not going to be a true statement or solution. Okay, our last example then is a word problem, and we're going to read through this a couple times. If you need to read through it on your own more than once to really make sure you understand it and what they're asking, feel free to do that. The average number of calories a 120-pound person burns while walking briskly is greater than 240 times the number of hours the person walks. If this person walks for 3 hours, will he or she burn at least 500 calories? So right away, they're telling us an average. Now, we don't have to calculate the average. It's not like we're going to add a bunch of stuff up and divide by how many things we had. They've already calculated the average for us. So they're telling us that the average number of calories a 120-pound person burns. Now, sometimes when students see numbers in a problem, they just start grabbing at every single number in the word problem and doing some sort of calculation with it. But this 120, we don't actually need that. We don't need to know how much the person weighs, okay? We just need to know the average number of calories that a person burns while walking briskly, okay, is greater than 240 times the number of hours the person walks. So now I'm starting to get into some math lingo here, okay? So I have is greater than, and then I have times. So that's telling me that I need to use a greater than symbol. And then that times actually means to times. It means to multiply. So this first sentence is trying to get itself translated into an equation. So the average number of calories a person burns. So I'm just going to say, okay, this piece of information, the average number, I'm going to call that N. So that's the number of calories that they burn while they're walking briskly. And then I have is greater than. So I'm going to use that greater than symbol. 240, that's a number that I need to use because it's 240 times the number of hours. So I'll use H for hours. So I have number and I have H. Those are my variables. Okay, and N is actually the number of calories. So now I have my inequality set up, and now I can move on to this final question here. If the person walks for 3 hours, will they burn 500 calories? So 500 is the number of calories. They're telling me the number of hours. That's the value that I have for H. So I'm going to substitute that in. 240 times 3 for the number of hours that they're walking. So then I'll be able to evaluate this and get the value for N. So N is going to be greater than 720. So if a person walks for 3 hours, they're going to burn more than 720 calories. Here they asked, will they be able to burn 500 calories? Well, yeah. If they're walking for 3 hours and they're burning 720 calories, then that's greater than 500 calories. So yes, they will be able to burn more than 500 calories. So there is your homework or your set of practice problems for this evening. If you have any questions, please come in before school to see me or Mrs. Zucker. And good luck and do well.